on the stream. There. Okay. For real this time. Welcome to the inaugural Rec Talks. Our host today is Joker. He's giving the presentation by the numbers, creating with math. He's going to be giving a discussion about how using both simple and complex math can accomplish some really amazing things in Rec Room when working with the maker pen and circuitry. Before we get started, ask him a few questions. I will tell everyone, though, before I go into that, please don't be disruptive. I would hate to have to kick you guys from the room, but I will if it comes down to it. And at the end of the presentation, you will get the opportunity to ask any questions you might have. So first, Joker, when did you start playing Rec Room?
I started playing Rec Room, I think just about exactly a year ago. It might be a little over a year ago. I do know that the first room I released, train demo, came out, I think, almost to the day a year ago. Yeah, something like that.
Okay, what got you into creating in Rec Room?
So creating was the first thing I did in Rec Room. It was shortly after I got my my Vive. It was the first thing I checked out. I forgot how I learned that it was a thing, but I think I just checked out a maker room and explored some of the features that existed at the time, and I immediately jumped into it. I mean, I came to Rec Room after earlier on in my gaming career. I spent a lot of time. This is in the mid 2000s. I was playing a game called Entmod. It wasn't really a game itself. It was actually a mod of for Half-Life mods. So it was specifically made for Team Fortress Classic, and I played it on a game called Spin Co-op. It was made by a guy named Drunken Fool. I spelled with 2 zeros instead of 2 O's. I'm just hoping to run into him on the he was this is a sort of creative game, and I'm hoping to run into this guy at some point. But Entmod was kind of surprisingly a lot like the Rec Room creating experience, in that it had the social aspect where you were in a place with people, and you had a tool that was a lot like the maker pen, and you could spawn objects, delete objects, reorient objects. You could do scripting. You could spawn enemies and kill them and stuff. And I remember I have a distinct memory of hitting. This is back when we used Xfire instead of Steam, and I remember recorded the hours, and I remember hitting 2,000 hours playing that game. So that was kind of my life in the mid 2000s. And after that, I played like Gary's Mod and Minecraft, and they weren't really the same. Don't do this first. Thank you, though. Cool. Good to know. They weren't really quite the same, so I never got into them after Nmod sort of faded away. But this time last year, when I started playing Rec Room and I discovered the creative features, it was like a moment. My memory of it was like, oh my god, this is finally, like, I finally get to do the Entmod kind of thing again, and I just never went back. The first thing I did was I started working on train demo, and within a month of playing, I released that. I barely did questing or PvP or anything. Like, I honestly just started doing creative stuff, and I've tuned it ever since.
So what would you say is the biggest personal challenge that you run into when it comes to some of the creations you've made, some of the bigger things you've made?
Yeah, this is an interesting. We talked about this question earlier, and so things that are challenging in Rec Room, like I realized Rec Room is challenging in a lot of ways and on a lot of levels. Personal level is one of them, but some of the challenges in Rec Room, I realized the reason I kind of struggled with that question at first is the challenges in Rec Room can kind of feel to people like me almost like a feature sometimes. Because what I do, especially in the realm of circuits, is just a lot of problem solving, right? And so when there are challenges like limitations on features or things not working like they're supposed to, there are things that are plain frustrating. But sometimes just needing to work around something, to do a lot when you're creating, working around limitations and stuff, is actually kind of a part of the experience that sometimes I really enjoy. But beyond that, it's challenging on other levels. Personal level, I would say, managing time and stress when you do a lot of creating, especially someone like me who has a full-time career otherwise. Um, it can get really busy and it can get easy to forget to sort of manage your life. And I usually have a lot of projects going all at once, and because I write down all my ideas and I never forget them. Um, and so it's kind of hard to keep priorities straight, but it's I'm still here and still doing it, so possible.
Okay. My last question. By the way, you might want to change your outfit. I don't think you meant to put that on.
Thank you.
But my last question is, it looked nice on you. I'm not gonna lie. No.
Yeah.
The last question is, what creation or achievement in Rec Room that you've accomplished? What is something that you're most proud of?
Yeah, there's a lot that I'm proud of. Some things in different ways. Um, train demo is I'm going to talk about it in a little bit, but that was the first thing I made, and I was really proud of it at the time because there was nothing like it. There were some things that were similar, but that was my first experience really of innovating, of coming up with a concept that hadn't been tried before and hadn't been shown to be possible before. That's why I called it demo, because I was demonstrating that the concept was something that people could do. So I'm always going to be proud of that. Um, one of the achievements that's personally most satisfying to me was bowling pin theremin, which I'm also going to talk about in a little bit. And I think I'll talk about the reasons for that later. It's because it pulled in like all the things, a bunch of random things I'd learned. Um, More recently, I'm kind of starting to be really drawn to making. I'm starting to be more proud of like the art apps or the art rooms that I make. Just because it's really satisfying to be able to sort of capture an idea or a feeling or an experience um, and translate it into a VR experience in Rec Room. Those are all things I'm proud of.
Okay. Well, that was all I had question-wise. Like I said, we will have a opportunity at the end for anyone in the room, as well as anyone watching on Twitch, to be able to ask questions after his presentation's over. And I think at this point, it's time just to get into the presentation.
Right. Couple things I want to say while Drummer Geek is pulling up the curtains. The first one is thanks very much to Drummer Geek for organizing this, first of all, but just as importantly for building and designing the theater that you're all standing in. I think it looks really amazing. He had to point out all of the details that you don't really notice until you're looking really closely at it. And I think it's wonderful. So you can all thank Drummer Geek for a lot of this. And then just by way of incidental stuff, I want to mention you can all hear me, but your voice roll off is really low, and that's good because otherwise that could be distracting. It's also going to be kind of weird for me because I can't the audience is just kind of quiet. Personally, if you guys want to use your espresso stuff, and maybe if you're mad at me, if you want to boo me, you can be angry, and if you want to show me adoration, I encourage that, just because otherwise you guys are just a bunch of dead faces in the audience who are just fidgeting around. Yeah, so yeah, I want to get started with this presentation on math. So I'm not going to be lecturing math today. I want to get that out there first. I have tutorial videos where I teach how to apply math to circuits, and get really into the weeds. I'm going to try to avoid that today. My two main goals for this are, first of all, to expose the audience and you guys and anyone watching on stream and later. I want to expose what's possible in Rec Room when you know some math. Even if I don't explain how to do it now, I want to show what you can do if you take the time to learn by going out there learning math by itself, watching tutorial videos, whatever. And the other goal I have is to try and demonstrate sort of the effect of what you can do by applying mathematical concepts to building in Rec Room. By effect, I mean like in a sort of general sense, like special effects in movies, like visual and audio effects, just like putting math to work to make a thing happen as part of your experience. A lot of building in Rec Room comes down to creating the effect for like the emotional effect or whatever it is, the effect for the people who are going to be visiting your rooms and experiencing the things you build. first thing I have, sort of demonstrate that, it's already running, is a little demonstration of some geometry for you. I recently published a set of tools for 2D artists for drawing with. One of them uses just a couple of rotators to draw a perfect ellipse. And it will be perfect so long as none of the sort of glitchy gizmo bugs happen. So let's see if I can get this to work. And this just uses, I adapted a strategy that engineers use to draw ellipses on design drawings, and I applied it to a couple of rotator gizmos to make that work. So let's get this off stage.
Yes.
Hoping to show you guys a lot of stuff like that. Next thing I'll talk about is I'm going to go through some of the rooms I've made, some of the inventions I've made, and some of the tutorial videos, and just try the times I applied mathematical concepts to building and circuitry. First one, as I mentioned, the first room I released was train demo. And so, before I get into it, please stay in the audience. Before I really get into it, I'm going to try and thank people who from whom I've learned things along the way. Like as I talk about concepts that they help me with. But I want to get names out before I might forget. So I want to get names out first of all. People I really need to thank. These are mostly people who are very active in the Discord, the Rec Room Discord, which is a very helpful place full of very helpful people. Seb, Forbim, Jolly Dog, Sintiel, Trunks, Mortimer, Velp, and lots of others, especially the people in build advice. All very helpful people, and I am personally grateful to them. They came before me, and I learned a lot from them. But yeah, so talking about train demo, so one of the I'm going to try and phrase things in terms of the problems I had to solve using math. I think I need to unpack the circuit first of all. There we go. So train demo, for those of you that haven't visited, the way it works is the players are actually standing still on a train that isn't moving, and the experience, the effect comes from the fact that the environment is moving towards you and it's infinitely looping. As it goes behind you, it jumps back to the beginning and comes towards you. And all of the so that means the ground is separated into pieces, and they all need to line up so that there's no holes in the ground, and they need to line up perfectly so that they're not overlapping. Because in train demo, I've got trees and stuff, and if they're overlapping, that would look weird. So in order to get the circuitry for this to work, I needed to figure out how to. The train is traveling at a constant speed, and I needed to figure out how to time the environment pieces to reset so that they would land perfectly in the right place at the right time so that there was as little gap as possible. There's always a little bit of rounding error and stuff, but as little gap as possible so that the experience would be continuous and smooth for the players. Now, I can demonstrate exactly why this is important by changing some of the numbers. So this sign right here shows the current speed that the environment and therefore the train would be moving at. And if I, is that on, it's 100, okay. If I change that, without changing the timing of the circuit, then it's gonna start to break. Uh-oh, uh-oh. I am unable to change the variables in the circuit. I have seen this before, in fact. I go to configure it, and not seeing there's just no variables to edit. Do you want to have a look and see if that makes any difference? And change. Trying to think of a quick workaround for this. Actually, I might be able to do it this way. I might be able to just configure these real quick. I'm going to do that for the time being. This is exactly the kind of stuff It is not terribly surprising to happen. So I'm gonna, let's see, the speed was 100. Let's set it to half speed, which is 50. This is in centimeters per second, so 50 is half a meter per second. So this is the same thing, but moving at half speed, and everybody should be able to see these are coming in too early and they're overlapping with each other. And in train demo, this would mean trees on top of each other and it look really broken. Similarly, if I edit this to double speed, I apologize a little members of the audience who are about to get hit in the face, but that's kind of part of the experience. You're in the splash zone, so just try and enjoy it. So now the pieces are coming in too late, and there are big gaps in the ground, and that does not look right. So in order to make this work, so if I keep this at double speed, I need to use a little bit of algebra to determine the timing to make it so that they come in quickly enough so that they're lining up with each other. Could you back away, please? And I don't think you guys can see this, but the way the timing is controlled for this circuit is in a timer in this timer chip, and I need to input the right number here to make the timing right. And this is the first example of an application of math. It's just a simple algebraic formula. Speed equals distance over time. And if you do some algebra, you can determine that time equals distance over speed. So these pieces are 3 meters long. The speed is 2 meters per second. So time equals distance over speed. Right now, these are 3 meters long, and if I divide that by 2 meters per second, what I get is 1.5 seconds. So now if I just input that in here as 15 ticks, now these start lining up a lot better. Again, not perfect, but that's the difference that makes. I'm going to skip doing the same thing with half speed. But so that's just a simple application of an algebraic, of using algebra to make this work when it wouldn't work otherwise. And even more than that, I can actually automate this process using the math chips in Rec Room. Because all I'm doing here is dividing one number by another number, I can use this, which is a division chip. In here, I've input this is red divided by green, and I've input the length here. And if I divide that by the speed, so distance divided by speed, I can just output this straight into the timer chip. And now anytime I change the speed here, variables chip, no, it's not working yet, okay. So if I change these speeds now to anything I want, it's automatically going to calculate what I need. So I'm going to turn this up to 3 meters a second, one by one. And now the chip is doing the work for me. And oh, is it? Oh, right. It's because I need to put it in here. Okay. Okay. So assuming this variable chip worked, the number would be going to all the right places, and these would be lining up perfectly. This is happening because the room is full of people, and this is kind of the thing that happens when you have a room full of people in Rec Room. Train demo, I don't usually have that problem because it's a smaller kind of a small hangout kind of room. Let's see. Okay, so that's the first place. That's just a simple way you can apply algebra to make that kind of thing work. I'm going to delete all of this. Hopefully, it won't break anything. Hopefully, this will get better as I'm getting rid of ink. Some more algebra, almost the exact same thing. I used in a room called Okay, there. Wait. This is alternating, working and not working. Okay, so I made a room called Sword Players. Let me move on to that. Sword Players uses the exact same principle. This is a room where you fight a dummy that's moving a sword from one random position to another random position, and the speed at which the game is happening changes depending on difficulty level. And so to make that work, I need to be changing the speed at which the dummy moves the sword up and down according to, first of all, where he's moving the sword to, because it's random each time, and also the time at which it's happening. And I did that using exactly the same formula train demo. The algebra is a little bit different. This time I'm actually calculating speed, so that's speed equals distance over time. In this circuit board somewhere, all it is a division chip, and it's calculating the variables I need. And so it should actually, if I change the speed at which the game is happening, which I can do with, I think I have a variable chip here, it's probably not going to work. Yeah, okay, that's not working. Let's try. I'm not going to use variable chips anymore. Instead, I'm going to use these. Okay, so this is 20. It's moving slowly, and it's moving smoothly. If I reconfigure this to be a lot faster, the moves are happening every 0.7 seconds. You can say, oh, that looks a lot better too. Well, that's good, at least on my end. I hope it looks good for you guys too. Now the moves are happening faster, but the dummy and the sword are still moving smoothly because the speed at which they need to move is calculated according to the algebra I programmed into the circuit. Great. Before I leave this, I always thank my friend Jance, who months ago made this dummy model for me. He's he's a very helpful artist friend of mine. And I can get rid of this stuff. And so before I leave, and by the way, so it's not an accident that I'm talking about algebra a lot. Because most of the math that you have to do in Rec Room is just simple algebra. Well, most of the math that you have to do is multiplication, division, addition, and subtraction. That's also because, as of right now, those are the only chips that we have. And so that's what you end up using. So before I leave talking about algebra, I'll just try and briefly describe another application is unit conversion. This is from a tutorial video I did on a smooth wave function, which calculates the speed that you need a piston or a rotator to move at to make them oscillate smoothly up and down according to a wave function from a wave chip. And this, the reason I had to do this conversion is one of many sort of quirky things that happen in that are true about Rec Room. Whereas with a piston, dealing with speed and position is easy because pistons move to a position in centimeters, and their speed is in centimeters per second, so it all lines up pretty well. Rotators, on the other hand, position is set to a number of degrees, and so you would kind of think that the speed would be set in degrees per second, but it's not. Speed on rotators is calculated in rotations per minute. But it's okay to make that work. You just need to do some unit conversion using this algebra. I started out with degrees per tick because that's how the smooth wave circuit works. I'll unpack that in a minute. But I started with 10 degrees per second, multiplied that by 60 seconds in a minute to get the number of degrees in a minute, and then divided by 360 degrees in a rotation. 600 over 360 is 1.6. We can't put in decimal points in Rec Room, so I call that roughly equal to. And so if you look inside this chip, or this circuit board, this is the smooth wave circuit, and it's outputting right here. It's outputting a number of degrees per tick, and I'm just converting that according to the calculation that I did, which is all it's doing is multiplying by 2. This looks a little broken right now. You should be able to see the number 2 here. So it's just taking red times green, and this is the number 2. And that makes the effect of this flag waving back and forth look maybe not theoretically perfectly smooth, but smooth enough. So that's all the algebra I've got. Anything else? Okay. And next I'll talk about the weird chip, the weird function that not enough people are familiar with, and that is the modulo chip. That's from my digital clock tutorial. So I'll pack this right away. game clocks and clocks in general turn up in a lot of places in Rec Room, as they ought to. And usually people end up just using, you can use a time, usually people use like a timer chip or something else to count the number of seconds counting up or down. And it's easy to get a number of seconds to count time in Rec Room. And some people just leave it at that. A sort of infamous example for me is Trouble in Terrorist Town, which they have a game clock that starts out at like 500 seconds and counts down, and it's really hard to figure out how much time is left because what does that even mean? So sometimes, oh, this is sticking into the wall a little bit. Fix that. So usually it's more desirable to convert a number of seconds into a number of minutes and seconds. And you can do that using digital clock. I have a tutorial for that. I'm not going to explain like everything about how it works, but I just want to talk about the lesson here is just use the modulo chip, and it's not that scary because calculating the number of minutes from the number of seconds, you divide by 60. That's just 60 seconds in a minute, so that's pretty straightforward. But after you've done that, you need to, if you want to know, the question is, how do you find the seconds remaining in the current minute? And that's all the modulo chip is. It finds the remaining seconds after you've already found the number of minutes. And in fact, I need to move on to the next slide. In fact, that's actually the best way to explain what the modulo chip is using a clock. It's because it's easy for us to think about the number of remaining seconds in a minute. We do that all the time. And really, all a modulo chip is doing exactly that kind of thing. It's remainder after dividing, the remaining seconds after dividing into a minute. So the lesson is just don't be afraid of the modulo chip just because it's weird. This doesn't get taught in, at least where I'm from, modulo function doesn't get taught in many math classes, which makes it seem like it wouldn't be very simple, but it actually is very simple. So like all the things I'm going to talk about today, please don't be afraid to use them, and it's going to make your build, the things you build in Rec Room a lot better. Great. Have a little bit of, actually, a little bit more to say about modulo. Another sort of maybe hard to understand application of it, but I think is really exciting if you can get your head around. And that is, okay. So I don't have an exciting demonstration for this one. This is, we'll call it encoding and decoding, or really separating large numbers by decimal place. I'm going to keep this one brief because it's sort of the more dry part of it. But like I said at the beginning, in the spirit of exposing the things that are possible in Rec Room, I really want to get this out there because I hope a lot of, at least some people in the audience, will appreciate how much it can be used for and take the time to figure it out and apply it to the things they're building. Because it's one of the things that's not fun to figure out necessarily, but it could be really powerful if used correctly. And let me just get my sign out of the wall, first of all. Okay. So, pack these. So what this is about is, okay, I apologize if my headset crashes. I'm on Vive Wireless, and it's kind of an inevitability. I've been okay so far today, but if I suddenly fall into the floor, that's what happened, and I'll be back hopefully within 2 minutes. So what this is about is you can take a large number with a lot of decimal places, like this 7-digit number I have right here, and it's possible using modulo chips and division chips, modulo function and division function, to separate that number and sort of isolate different ranges of decimal places. Let me just demonstrate that first of all. Demonstrate that by cycling through a couple, I've got a couple different longer numbers here. And you can see as these numbers are changing, it's being split into these 3 numbers which are independent, which are totally independent of each other, and being sent into this sign prop from the circuit. And actually, so all that's happening here is really to make this work, you're just sort of, I have to use the variable chip for this. Uh-oh. Might have to not really get into this very much. Okay. Yeah, the variable chip's going to make this not work. So, but I could still kind of explain. All I'm really doing here is changing, I think these output chips should be visible to everybody. I'm using different powers of 10, 1,000, 100, 1 million, 10,000, and such, to sort of carefully isolate different parts of this number from each other. Right now, it's separating into 3 different numbers, but there's actually the limit for that is a lot higher than that. This is just for this demo. There is a limit, but it's higher than you guys are going to need to worry about. And so, yeah, let me get into what this is useful for. This is useful when you want to store information, a lot of information, really efficiently. When you want to store information or transmit information really efficiently. As an example, I've got a state. Notice I've got a state machine here. Those of you that are already familiar with state machines, and what we end up with is 3 numbers. This. What we end up with is 3 numbers, but if you pay attention, on the state machine, I'm actually only using one of the pins right now. So start out with 1 number, end up with 3 numbers, and I'm only using 1 pin. But for those of you that know state machines, you can actually use all 3 of the pins at once because each state chip holds 3 values. So if I did this same circuit for each pin, I could actually store 9 different numbers in each state chip. And like I said, that's not even close to the limit. You could use this same strategy of encoding. So we can call this encoding. If you take these 3 numbers and make them, and the process is just this in reverse to make this happen, the large number, and then you can decode them into more smaller numbers. What that's useful for example, are things like the most interesting is probably something like player stats. Anyone who's familiar with stat chips, there's already 6 slots for stats, but if you want to make a really big complicated game like an RPG or something, and you want players to have the ability to do stuff like, make sure nobody's trying to tell me anything right now. If you want to do stuff like give people different weapon types, different armor types, lots of different roles, and if you're going to have more than 6 bits of information that you need to store, then this is what you can do to store that kind of information. You can do the same thing with teams. Each team in Rec Room in a game has 1 team score, but you can use this kind of strategy to make a team score into a bunch of different bits of information, like I don't know, maybe, I don't know, I can't really think of anything right now. I haven't built many team games, so I don't have much imagination for that. But yeah, I specifically want to thank Seb, Jolly Dog, and Scintial. They're the ones who exposed me to this kind of strategy. I know Scintial, for his part, used this in his Monopoly room, which is amazing and ridiculous for those of you that have seen it. And I think I'm actually just gonna breeze over this. This is a general idea, but because the variable chip is broken, this is a general idea. A specific application of it is you can actually do rounding. Like if you need to divide a large number in Rec Room, the way division chips work is they totally forget about their remainder, which means you can there's sort of a potential for a lot of rounding errors, and it's possible to use this to isolate the decimal place after a division, and then use that decimal place to decide whether or not you should round up or down. And this is an example of that. That basically just uses, and then plus a comparator chip. All this is looking for is whether or not the number that comes out is less than or equal to 5. It's just, or greater than or equal to 5. If it's more than 5, you round up. So, okay, so yeah, I did want to mention the rounding circuit because one application of rounding was my theremin I did mention earlier. And I would like to show that to everybody first. Okay. Oh, a little too far. There it is. Okay. 1 second here. I need to water. So I'm pretty proud of the theremin because, and I also sort of this is a sort of decent example of what I was talking about with Drummer Geek a little bit earlier. Sometimes it can actually be kind of exciting and interesting in Rec Room to have to deal with the limitations that we're presented with, right? So right now, there's no easy way to create like an analog control. The only way to do it is to use something totally silly that doesn't fit, which is a bowling pin. And I'll explain exactly how that works on the bowling pin slide. Okay. Here's a giant bowling pin, and let me make sure to unwire this first of all. There's a couple things I want you all to notice about the bowling pin. The first thing you should notice is it's really, really big. Bowling pins aren't usually this big. And when you get it this big, you can kind of see it's really dirty on the bottom. And I don't know, that's weird. Like, what's up with that? I don't know if it's supposed to be wax from like the bowling lane or what, but it's just kind of like you'd think they would clean it. The other thing is, so the thing I really want to talk about is the pins from the bowling. I'm going to ignore the red pin. The green pin from the bowling pin is it's this outputs the angular position, which should be going to, okay, so that's going to this sign. The green pin outputs the angular position. I can demonstrate that by rotating, make sure that is still. So, okay, let me explain a little bit more here. I'm gonna keep that silent for now. So if I rotate this, you can see the angular position goes to that sign. Okay, it goes from 0, which is straight up, all the way down to 180, which is straight down. So what I was talking about is analog controls. All that ultimately means is you need a way to get a number or to control a range of numbers in a really smooth analog way. And as you can see right now, that's what you can do with the bowling pin. And there's going to be a lot of applications for that for sure. But what I wanted to do was I wanted to see if I could create a musical instrument using that analog control. And I was able to do that using samplers. Specifically, and I need to explain a little bit about the sampler. The sampler has its own green pin, but it's an input pin. The input pin on the sampler plays the sampler faster and faster depending on what you set this number to. And the thing about it is the way playback speed works is it doesn't just increase the speed; it also increases so the sample rate so that the frequency actually increases on the sampler. So, for example, if you've got the sound of somebody's voice in a sampler and you play it at double speed, then they're going to start to sound like chipmunks, right? Because their voice pitch goes up really high and it's going to sound really funny. So what I did with this sampler, and I'll watch your ears a little bit, is this sampler has recorded a steady 55 hertz tone, which I generated using Tux Guitar or something. For those of you that know music, 55 hertz is the A1 key, which is way down the piano. It's really low. And what I wanted to do was use circuitry, I ended up using the bowling pin, to increase the playback speed in such a way that I could control the tone. I could vary the tone by varying something in the game world. So if I delete this, this tone is really low and most of your speakers aren't going to be able to produce it at first. I'm also going to, in case it's too loud for anybody, turn it down a little bit. So let me demonstrate. Doing the same thing as before, if I rotate this, this number is getting sent in and it's speeding up the playback and it's making it a higher pitch. You all hear that? Good, yeah. Samplers aren't the most reliable thing, so I just want to make sure everyone can hear it. So this is the basic idea. I wanted to use this to make a musical instrument. And right now I can't. It's kind of hard to make music with it because it's kind of hard to control the range, and also a very specific problem I'll try and explain here. This is where math starts to come in. So for those of you that are familiar with music, the way the musical tonality works is some of the basics of it is if you have a note and you want to go one octave up from that note, then you're taking the first frequency and you're doubling it, right? So I can demonstrate that by inputting a number here, and unfortunately you guys aren't going to be able to see it. So I'm going to start by, so if I can rotate this specifically to 40 degrees. So there's 40 degrees. 39? Okay, close enough. Okay, that's just a working little thing. So, but call that 40 degrees. I wonder if I just... There we go. That's 40 degrees. So right now, this is receiving the number 40, which is setting this tone to a new pitch. And if I double that, for the musically inclined people in the audience, you're going to hear, if I go from 40 to 80, it's going to sound exactly one octave up. I'm going to try 82. Make sure it actually hits. Okay, so let's go from 81. So listen for the octave. So that's one octave, and if I want to go yet another, this is an A tone. If I want to go another octave up, I need to double that again. So let's try 161. So I have some control. I can start out with, I can go through a few octaves. But the problem you'll notice is, so look at the difference between this note and this note. The rotation of the pin is fairly small, and if I go up to the next one, that's a lot bigger because it's doubling every time. And so that's a problem with if you want to control this, if you want to control a pitch, that's going to be kind of difficult because every octave you go up, you start to have to go twice as far and farther and farther and farther. So that leads to the problem, which is how do I make the tone go up faster and faster as I go through different octaves? And that is what I solved using a math circuit. Now, I should delete this. That's all good. So here is the theremin. This is available in the Invention store, by the way. I've had a lot of fun with it. We had some problems with this in rehearsal, so I want to make sure it's not broken. Pack this right away. So the question was, how do I increase the frequency faster with each octave? And the answer is a mathematical function, a very specific one. It's an exponential function. I had to use a function of the form 2 to the power of x, where x is the variable, and the variable is coming from the bowling pin. Now, the problem with that is, let me unpack this. Actually, no, I'll introduce it first. So I needed to do 2 to the power of x. So yeah, again, you're going 20, 40, 80, 160, multiplying by 2 every time. That's 2 to the power of x. To model that function is not really possible in Rec Room right now. I've shown you just about all the math chips, and right now there's no power function math chip. You can multiply, but you can multiply two variables together, but you can't raise some number to the power of a variable. Not yet, anyway. So in order to make this work, I did end up making it work. I had to use something called piecewise linear approximation, and that may sound a little scarier than it is. All it really means is we're back to algebra. I talked a lot about algebra at the beginning, and all this ends up being is some linear algebraic functions, and they're sort of stitched together to look like a curve, all right? So it would have taken too much ink to draw a curve, but to draw the function I want, but 2 to the power of x is a curve, and you can model a curve using piecewise linear approximation. The way I did that is circuit, which I'll show you now. Nope, nope, nope. There we go. Okay. So going back to the algebra, an algebraic function is always of the form, if you have numbers a and b, and those are constants, it's a times x plus b, ax plus b, right? And so that's how I made the different lines, the different functions that model the 2 to the x function that I need to make this work. And all that's here behind me are, this might look complicated, but I kind of want to point out to everybody, all this is the same circuit copied 3 times, right? This is exactly the same as this, is exactly the same as this, and that's because these three circuits are all just how I programmed in a linear algebraic function, and the selector, as I move through the range of possible tones from the theremin, the selector just moves through the different lines to make up a curve. That's all a kind of complicated way of saying I have 3 octaves that are possible in this theremin, and as you go from octave to octave, the slope of that function doubles. So down here it's 1, here it's 2, and up here it's 4. It's actually more complicated than that, but the general idea is that as you move through, the increase in the frequency in this sampler goes faster and faster, which is exactly what I wanted to make this work. Oh, before I move on, I mentioned, so it's right now there's no, like I had to use linear approximation to make this work, because right now there's no way to do a power function or square or any kind of power function in Rec Room. There is a Canny request for that. For the audience who are, especially those of you who are watching online, I really encourage you guys to use Canny in general in the first place, but this is the request to make power functions work. It could make some things a lot easier and maybe a lot of some other things possible in Rec Room, and I think it could be really useful. And so I want to demonstrate this, but first I want to note there isn't. I do want to talk about. I'm talking about math a lot today. That's why I'm here. But this also, the theremin is also a good example of sort of the limits of applying math in Rec Room. And the way I'll explain that is, for like builders, for example, maybe especially architects. You know, if you're if you're designing something really specific, like even if it's symmetrical and sort of has maybe that kind of mathematical quality to it, you still don't always use math to make it look perfect. Sometimes it's just better to eyeball something and to tune it carefully to get it to work than to spend the time calculating. This is kind of an example of this, or the theremin is an example of that, because these are essentially the same as the keys on the keyboard of a piano. And to place these, I used a rotator to move them around. And I could have, if I really wanted to, calculated the angular position that I needed to get every tone that I wanted, but I didn't do that. Instead of what I did is I just attached the rotator, and then I moved until the tone was appeared to be as close as I could get it to the tone that I wanted. And when I got there, that's where I placed a key and I would color it and such. It's sort of the same as tuning a guitar, right? When you're tuning a guitar, you don't calculate the angular position to turn the machine head to get the right wave speed on the string. You just tune it, you turn it until it sounds right, and that's how you tune an instrument, right? So that's sort of right. Like, math is useful, but don't use it for everything, or don't feel like you need to use it for everything. Save yourself a lot of energy by learning to tune things. I like to think, by the way. I feel that essentially what I did with this is that I tuned it to make it work, and I know I'm not the first person to build a musical instrument in VR. I know there's some VR games or software out there that you can use a musical instrument, and I know I'm not the first person to build a musical instrument in Rec Room. I think there have been a couple of pianos, but I like to think I'm the first person to ever tune an instrument in Rec Room. I can't imagine, or to tune an instrument in virtual reality. Can't imagine anyone's ever done that before. So that's part of the reason I'm really proud of this. Is it's something I never imagined myself or anyone else having to do. So let me get around to demonstrating this for you guys. I'm sure you want to hear it. Hopefully it doesn't bug out too bad. Need to get my wand. My wand's ready. So for those of you that don't know what a theremin is, I do not blame you. It's a very obscure instrument for nerds. It uses electromagnetic fields. Actually, you stand near it and you hold your hands, and you hold your hands near a couple of coils, and just sort of the mass of your hands interfere with the electromagnetic field, and then that creates pitch and volume on the theremin. And I've sort of modeled that by having a couple of props that you hold in your hand. That is still oh no, it isn't. A couple of props that you hold in your hand. This one controls volume as I lift it up above the coil, and this one chooses a tone, and I'm not the authority player, so it's kind of laggy. Okay, I won't be able to play you guys the beautiful music I really wanted to because I'm not the authority player. Yeah, but I think I can play through the major scale for you. So again, well, let's do a suite first of all. You guys hear that? Sampler's working all right? Good. So this is different from the bowling pin before, where with the bowling pin, the increase in frequency was slower and slower the higher I got. This is even in the tonality as I move through it. I can prove that by trying to play a major scale, even with all this lag. I was gonna play Epona's song. Let me give that a try. That's a little slow, but it worked. Oof. All right. So that's the theremin. And yeah, I segued into this from the rounding circuit, by the way, because I have to do a lot of division with this, and I really, really wanted the frequency to be as accurate as possible. In order to get rid of the rounding errors as much as I could, I used this rounding circuit. This is more or less what you guys saw before, but I've got 3 of them for each function, and that's how I got it as accurate as I possibly can, because human ears are pretty good at picking out, unless you're tone deaf, pretty good at picking out when the pitch of something is just a little bit off. And you guys know that because you just heard me play Epona's song, but it didn't sound very good. So that's just a couple other things. I can move on from this. All right. That's okay. I have one more demo, but first, so before I get to the end, these are all people I thanked earlier, but I want to these are also great examples of people, but also rooms that have not only applied mathematical concepts to do really interesting things in Rec Room, but these 3 guys are examples of, they're sort of on the leading edge of developing new concepts for the rest of us. I know I've learned a lot a lot of stuff that I sort of take for granted now were generated by these guys experimenting with computer science and math concepts to try and bring them into Rec Room in the first place. And these, I originally had pictures of the rooms up here, but that took up too much ink. So I just encourage you guys to have a look at these rooms. Seb, Four Moon, Jelly Dog. Pixel Perfect was, I mean, Pixel Perfect was personally kind of a big inspiration to me because I saw how complicated what Seb did, what that was, and I saw that it was interesting, even if not itself a really sort of deep experience. It just sort of showed the power of experimenting and making some, just like the sort of, it was inspiring to know that you could just spend the time to make something work and be that passionate about it. I wish I could say that a little better, but I encourage you guys to check out the stuff that these guys make. Corbin did figure out how to make square root circuit and also a power circuit. Um, and I forget what Seb used for lazy target practice, but he has it's with a lot of Seb's rooms, you can view the circuits that he used. He usually has a separate subroom that you can look at. So if you want to have your mind blown or get really confused or both, have a look. All right, I think that's it. I don't have any more. So the last thing I want to demonstrate for you guys, I'm going to bring back out what I showed you at the beginning here. This is sort of an illustration of, so this ellipse, there are a few times in Rec Room when I've been designing something or coming up with a new idea, I've had to go and learn something new, something mathematical, in order to make it work. And so it's sort of an important thing about Rec Room to me that it makes me want to learn new things, especially with math, in order to make something work. Some examples of this are the elliptical drawing tool. Like I said, I had to research how strategies engineers used on design drawings in order to find something that I could adapt into rotators to draw an ellipse. Another example was the piecewise linear approximation. I needed to research ways that mathematicians and computer scientists could model power functions when they didn't otherwise have a way to do that. Another thing I learned is what I want to demonstrate right now. If I need to go back, let me erase this first. I learned that a strategy for drawing the ellipse is actually really similar to drawing another more interesting kind of polar function. And if I just tweak what I've got here, I need to pitch this. Pitch this one back 180 degrees. Roll this 180 degrees. Unwire this one, put back. Just a couple tweaks to the elliptical drawing thing. I've got another polar function. One's called a cardioid. I remember cardioids because I learned about them in my upper level calculus class at university. And I just have a distinct memory of my math professor who's a sort of old, sort of boring, kind of goofy guy, just going through the lecture, and then he demonstrated this, and he drew it, and then he kind of turned to us and said, "This is called the cardioid function," and then he just kind of said, "For obvious reasons," without really any humor, and this is what was drawn on the board. So that's the function I have for you guys. And that's all I have for today. Grammar Geek.
All right. Thank you very much, Joker. Now, like I said at the beginning, we're going to allow anyone in here who has questions to ask them. If anyone has a question, raise your hand. I'll bring you this microphone, which will allow your voice roll off to be high enough for us to be able to hear it. Does anyone have a question? I think you might have blown their minds.
You guys really want to ask like circuit questions? At first, I could kind of get into it, but again, this is supposed to be more just like for fun. Hey, Phil. I'm up for talking to Phil.
Okay.
Usually.
Yeah. Here you go.
Hear him.
Oh, hold one
Hear
second.
him.
It's the rolls aren't updating immediately. Just hold on to the mic for a second.
Okay.
We had. Oh, there we go.
I got him.
You mentioned your tutorials earlier. Where can people find those?
So there's a lot. I mean, if you go on the Rec Rooms YouTube page, they have a tutorial playlist of community tutorials, and I have most of mine are on there. Not all of them. The ones that aren't, you can find in the well, actually, yeah. go there, you can find my account and my YouTube account, and then see all the videos I've uploaded. That YouTube account right now is basically only tutorial videos, so those are all mine. But meanwhile, while you're on the community tutorials playlist, there's lots of other tutorials. For example, there's a couple by A Few Good Tacos, who's giving his own talk a little bit later tonight. Today, depending on your time zone. And also keep an eye on the tutorials channel in Discord. There's always new tutorials coming out there, and some of them are really helpful.
All right. Does
And
anyone
I
else
do plan
have?
on doing more tutorials, so I'm not buried under other projects. It's been a few weeks since I released one.
All right. Does anyone have anything else? Anyone?
Are there any coming in from Twitch?
Nah, we didn't have too many viewers on
Twitch,
Twitch. Except for one person who asked if they
Sorry.
can help build, which I'm not really sure what they were asking if they can help build. So,
I mean,
but all right,
happy
well,
for people to do my work for me.
thank you again, Joker, for this. Just so everyone knows, I will be uploading this talk to a YouTube channel as well that I have basically just dedicated to Rec Room videos, my tutorials, and these Rec Talks. And I will share a link out to it in the on the Rec Room Discord under the events. So look for that. And if you guys are going to be on for a while, here in about, I think it's about 40 minutes, we're going to be having another Rec Talk with A Few Good Tacos, if anyone wants to come to that. And I thank you guys for coming and hope to see you at future events. Turn lights on.
I was going to shoot myself with a gun.
Won't work.
Oh, it won't? Okay. Okay, I have no other way